The night is cold and clear. You're looking through the eyepiece of a telescope, searching the vast velvet blackness of space. You scan past the familiar diamond points of distant stars, past the steady silver light of Jupiter, and then you find it. At first, it's just a pale yellowish dot, unremarkable, but as you adjust the focus, turning the small knob with a delicate touch, the dot begins to resolve. It sharpens, coalesces, and in a sudden, breathtaking moment of clarity, it happens. The dot transforms into a perfect, tiny sphere, impossibly suspended in the darkness. And around it, impossibly thin, impossibly elegant, is a ring. It doesn't look real. It looks like a drawing, a perfect diagram from an astronomy book that has somehow been pasted into the sky. It is serene, silent, and utterly alien. There is a sense of profound order and artistry to it that feels out of place in the chaotic cosmos. This is the feeling that has captivated every human who has ever laid eyes on it, from Galileo Galilei in 1610, who at first thought he was seeing a planet with ears, to the amateur astronomer in their backyard today. It is a moment of pure, unadulterated wonder. This single elegant image is our starting point. It is the serene mask that hides a world, or rather a system of worlds, so bizarre, so extreme, and so wonderfully weird that it constantly challenges our understanding of how a planet should behave. This perfect jewel hanging in the void is an invitation. It beckons us to come closer, to look past the beautiful, simple form and uncover the complex and chaotic truths it conceals. It is the gateway to a journey into one of the solar system's greatest enigmas.
To truly appreciate the weirdness of Saturn, one must first appreciate how different it looks from everything else. Scan the night sky, and the other planets offer their own subtle charms. Venus is a brilliant, featureless beacon. Mars is a tiny, rusty red smudge. Jupiter, the king, is a bright, commanding presence. And with a good telescope, you can just make out its faint cloud bands and its 4 largest moons, dancing in attendance like loyal courtiers. They are all magnificent, but they are, recognizably, worlds. They are spheres. Saturn is something else entirely. It is a statement. The planet itself is a beautiful, pale, butterscotch-colored ball, but it is the rings that elevate it from a mere world to a cosmic icon. They are so geometrically perfect, so crisp and well-defined from this distance that they break our sense of natural cosmic order. Moons are spheres, asteroids are lumpy rocks, galaxies are ethereal swirls. But here is a planet wearing a halo, a vast, flat disk that seems to defy the very gravity that holds the planet together. This initial impression of impossibility is not an illusion. It is the first clue that the rules of planetary formation and behavior are different out here in the cold outer reaches of our solar system. The sight of Saturn doesn't just inspire wonder, it provokes a deep sense of curiosity. How can such a thing exist? What is that incredible structure made of? How can it be so vast and yet so impossibly thin? The planet's serene beauty is a challenge to our understanding. It doesn't just sit there, it asks questions. And the answers to those questions are far weirder than the initial sight would ever lead you to believe.
Let us begin our journey with the planet itself. The Romans named it after Saturn, the god of agriculture, wealth, and time. They saw its slow, stately, and predictable journey across the night sky and associated it with the inexorable passage of the seasons. But if they had known what the planet was actually made of, they might have named it after a god of air, or clouds, or nothingness. For the first and most fundamental weirdness of Saturn is its profound lack of substance. It is the least dense planet in our entire solar system. In fact, it is the only one whose average density is less than that of water. This leads to the most famous, almost cliché thought experiment in astronomy. If you could find a bathtub, a cosmic ocean large enough to hold it, Saturn would float. It is a concept so bizarre it's difficult to fully comprehend. We think of planets as solid, heavy things, as great, rocky worlds like our own. But Saturn is not like that. It is a celestial puffball, a giant ball of gas and air so light that it would bob on the surface of a vast imaginary sea. Imagine the sight. This colossal world, 30 times larger than Earth, not sinking into the depths, but floating placidly, its magnificent rings casting a shimmering reflection on the endless water below. This single fact tells us more about Saturn than anything else. It is not a place of solid ground. It is not a world you could ever stand on. It is an atmospheric entity, an immense spinning globe whose very existence is a contradiction to our earthbound intuition. It is a planet that is barely there at all, a ghost of a world masquerading as a giant.
The reason for Saturn's incredible lightness is simple: its composition. Like its larger sibling, Jupiter, Saturn is a gas giant. It is made almost entirely of the two simplest and lightest elements in the universe, hydrogen and helium. It is, in essence, a tiny star that never was. It gathered the same raw materials as our sun, but it never accumulated enough mass to ignite the fires of nuclear fusion at its core. And so it remains a colossal, cold, and dark ball of gas. If you were to descend into Saturn, you would not find a solid surface. You would simply fall through ever-thickening layers of clouds. The pale butterscotch color we see from a distance is just the top of its atmosphere, a hazy layer of ammonia ice crystals. Below that, the pressure begins to build. The hydrogen gas, at first thin and ethereal, becomes thicker, denser. Deeper still, the pressure becomes so immense, thousands of times greater than the surface pressure on Earth, that the hydrogen gas transitions into a bizarre state of matter, liquid metallic hydrogen. This is a substance that does not exist on Earth. It is a sea of hydrogen atoms pressed so closely together that their electrons are squeezed free, flowing like a metal. This vast spinning ocean of metallic hydrogen is what generates Saturn's powerful magnetic field. But there is no solid ground to be found. You would continue to fall until you reached a small, hot, and dense core of rock, ice, and metal, perhaps only twice the size of Earth, crushed under the unimaginable weight of the planet-sized atmosphere above it. Saturn is, for all intents and purposes, a world made of air.
Like our own planet,
Saturn does not spin perfectly upright. Its axis is tilted, leaning over at an angle of about 27 degrees, very similar to Earth's own 23-degree tilt. And this tilt means that Saturn has seasons. As the great planet makes its slow 29-year journey around the Sun, different parts of it are exposed to more direct sunlight. It has a summer, an autumn, a winter, and a spring. Each of these seasons, however, is a slow-motion epic, lasting for more than 7 Earth years. A Saturnian winter in the northern hemisphere means that the North Pole is tilted away from the Sun, plunged into a long, dark, and frigid twilight. A Saturnian summer means the pole is tilted toward the Sun, bathing it in continuous, though weak, sunlight. We can observe these seasonal changes from Earth. We have seen the planet's colors shift as different atmospheric hazes are produced or dissipated by the changing sunlight. We have even seen the rings play a role, casting vast shadows upon the planet's surface, a shadow that grows and shrinks with the passing of the long years. The very existence of these seasons on a gas giant is strange enough, but the tilt that causes them is itself a profound mystery. Planets are like colossal spinning tops. They tend to want to stay spinning in the same orientation they were formed in. A massive gas giant like Saturn should be very stable. So why is it tilted? For decades, scientists were puzzled. The gravitational pull of the distant planet Neptune should have, over billions of years, slowly pulled Saturn upright. But it hasn't. Something else is at play. Something inside the Saturnian system itself is pulling on the great planet, keeping it perpetually off kilter.
The answer to the riddle of Saturn's tilt appears to lie not within the planet, but within its vast and complex family of moons. For a long time, the leading theory was that a gravitational resonance with the planet Neptune was responsible. But recent data from the Cassini mission has upended this idea, pointing to a more intimate and perhaps more chaotic cause. The culprit, it seems, is the relentless outward migration of Saturn's largest moon, Titan. Titan, a world larger than the planet Mercury, is not in a static orbit. It is slowly, almost imperceptibly, spiraling away from Saturn at a rate of about 4 inches per year. This might not sound like much, but over the 4.5 billion-year history of the solar system, it adds up. The physics is complex, but the idea is that as Titan moves further away, its gravitational pull on Saturn changes, tugging on the planet's equatorial bulge. This constant, gentle tugging has, over eons, tilted the entire planet over. This discovery is a perfect introduction to the true nature of the Saturnian system. It is not a collection of separate, isolated objects. It is a deeply interconnected web of gravitational relationships. The planet affects the moons, and the moons affect the planet. And as we will see, the rings affect the moons, and the moons affect the rings. Nothing exists in isolation. The beautiful, serene picture we see from afar is the result of a constant, delicate, and often violent dance between all the members of this strange and wonderful family. The mystery of the tilt is our first powerful clue that to understand Saturn, you have to understand all of its parts at once.
We leave the planet behind, a colossal, pale globe receding in our imaginary viewport. Our destination is the shimmering, impossible structure that encircles it. From a distance, it appears as a solid, cohesive thing, a single, flat plane of light. But as we draw closer, its true nature begins to reveal itself. The single band of light resolves into distinct, separate rings: the A ring, the B ring, the C ring, each a broad concentric circle separated by gaps of seeming nothingness. The scale is monumental, hard to articulate in earthly terms. The main rings, stretched from end to end, would not fit in the space between the Earth and our moon. It is a structure so vast that our own planet would look like a small marble rolling across its surface. As we get closer still, these broad rings resolve even further. We see that they are not solid at all, but are themselves composed of thousands upon thousands of smaller, finer ringlets, packed together like the grooves on a cosmic record. The sheer complexity is breathtaking. There are bright, dense ringlets and dim, ethereal ones. There are sharp, well-defined edges and soft, blurry ones. The system is a tapestry of intricate, ordered chaos, a symphony of orbital mechanics playing out on a scale that dwarfs human comprehension. This is not a static place. It is a system in constant, silent motion. Everything here is in orbit, moving at incredible speeds, thousands of miles per hour. It is a blizzard, a river, a dance of countless individual partners, all held together in a gravitational ballet choreographed by the giant planet at its center. To approach the rings is to witness the raw, beautiful mathematics of the universe made visible.
The first paradox of the rings is their immense width. The second, and perhaps even stranger paradox, is their incredible thinness. While they stretch across hundreds of thousands of kilometers of space, their vertical thickness is, for the most part, astonishingly small. In most places, the main rings are only about 10 meters or 30 feet thick. That is roughly the height of a 3-story building. Some regions are even thinner. Let us try to grasp this with an analogy. If you were to build a scale model of Saturn that was the width of a standard football field, the rings in your model would be thousands of times thinner than a single human hair. They are, proportionally, the flattest, thinnest structure ever observed in the cosmos. They are a celestial sheet of paper, a razor's edge slicing through the void. This is why every 15 years, Saturn's rings appear to vanish from our telescopes on Earth. As Saturn makes its journey around the Sun, our viewpoint from Earth aligns perfectly with the ring plane. We see them edge on, and because they are so impossibly thin, they simply disappear, their vast expanse reduced to a single, invisible line. For a few days, Saturn becomes just a simple, unadorned sphere, a pale imitation of its true self. This periodic disappearance is a beautiful, recurring reminder of the ring's true, delicate, and wafer-thin nature. It is a cosmic magic trick, a disappearing act, played out on a planetary scale.
So what is this vast, impossibly thin structure actually made of? If we could plunge our hand into the rings, what would we feel? The answer is both simple and beautiful. The rings are made almost entirely of water ice. They are, in essence, a cloud of frozen, floating, glittering water. The particles are astonishingly pure, which is what makes them so bright and reflective. From a distance, they look like a solid band of light, but in reality, they are a swarm of individual, disconnected icebergs, each on its own independent orbit around Saturn. The size of these ice particles varies enormously. Most of them are small, ranging from the size of a dust mote to a grain of sand to a small pebble. But scattered amongst this cosmic dust are larger members. There are countless chunks the size of a car, millions more the size of a house, and a few behemoth icebergs as large as mountains, all tumbling silently through the vacuum of space. The entire system is a grinding, churning blizzard of ice, a debris field of frozen water of every conceivable size. If you could float within the rings, it would be a scene of silent, crystalline beauty. You would be surrounded by a slow-motion storm of glittering ice crystals, tumbling and turning as they catch the distant sunlight. Giant, city block-sized icebergs would drift past with a slow, majestic grace. It is a place of profound silence, the only sound being the very faint, occasional crackle of static electricity. It is a universe made of frost, a realm of suspended, frozen water that has been orbiting Saturn for millions of years.
This vast swarm of ice is not uniform. It is organized into a stunningly complex structure of rings within rings and gaps within gaps. From the outside in, astronomers have given the main rings simple letter designations. Furthest out is the faint F ring, then the broad and bright A ring. This is separated by the most famous gap, the Cassini division, from the B ring, which is the largest, brightest, and most massive of all the rings. Inside that is the more translucent C ring, and even closer to the planet, the incredibly faint and dusty D ring. But this simple lettering system belies the true complexity. When the Voyager and Cassini spacecraft gave us our first close-up views, they revealed that these broad rings were themselves composed of tens of thousands of individual, narrow ringlets. Flying over them would be like looking down at a vast gray vinyl record etched with countless grooves. Some ringlets are perfectly circular, others are slightly elliptical. Some even have strange wavy or scalloped edges. The gaps, too, are not empty. The Cassini division, which looks like a clear black gap from Earth, is actually filled with its own faint dusty rings. Other, smaller gaps, like the Encke gap and the Keeler gap, are almost perfectly empty, swept clean by the tiny moons that orbit within them. The entire system is a rich, detailed tapestry of structure, a record of billions of years of gravitational interactions, collisions, and sculpting forces. It is not a single object, but a dynamic, evolving system whose intricate beauty we are only just beginning to understand.
How does such an intricate, delicate structure maintain its form over millions of years? A system of countless individual particles should, by rights, spread out and dissipate over time. The sharp edges and narrow ringlets should blur into a single featureless disk. The fact that they do not is thanks to one of the most charming and literal concepts in astronomy, the shepherd moons. These are small inner moons of Saturn that orbit near or within the ring system itself. They act as cosmic sheepdogs, using their own small gravitational fields to herd and control the ring particles. The most famous examples are Prometheus and Pandora, two small potato-shaped moons that orbit on either side of the faint F ring. One orbits just inside the ring, and the other orbits just outside. Their gravitational dance is what keeps the F ring a narrow, well-defined ribbon. The inner moon, Prometheus, moves slightly faster than the ring particles. As it overtakes them, its gravity gives them a little pull, causing them to slow down and fall into a lower orbit. The outer moon, Pandora, moves more slowly. As the ring particles overtake it, its gravity gives them a pull that speeds them up, pushing them into a higher orbit. This constant push and pull from both sides corrals the straying ice particles, keeping them confined to a narrow band, like a flock of sheep being guided by two vigilant dogs. This gravitational shepherding is happening throughout the ring system, a constant, silent process of cosmic maintenance.
While some moons shepherd the rings from the outside, others perform their artistry from within. Throughout the vast A ring, there are several narrow, dark gaps that look like someone has carved a perfectly empty groove into the system. For a long time, these gaps were mystery. We now know that they have been swept clean by tiny moonlets that orbit inside them. The most famous of these is the moonlet Pan, which orbits within the 325-kilometer-wide Encke Gap. Pan is a tiny world, only about 30 kilometers across, but its gravity is enough to clear a path for itself through the ring material. As it orbits Saturn, it acts like a tiny gravitational snowplow, absorbing some particles and kicking others out of its way, maintaining the gap for millions of years. But its influence is more subtle and beautiful than just clearing a path. As Pan moves, its gravity tugs on the particles at the very edge of the gap. This tug creates a series of beautiful, intricate patterns. It pulls the particles up and down, creating delicate, scalloped waves and ripples on the gap's edge that follow the moon as it orbits. The Cassini spacecraft captured breathtaking images of these waves, structures dozens of times taller than the ring plane itself, created by the passage of this one tiny moon. The smaller moon Daphnis creates even more dramatic, ruffled three-dimensional waves in the narrower Keeler gap. These tiny moons are not just inhabitants of the rings, they are active artists, constantly carving their delicate wavy signatures into the magnificent canvas of Saturn's rings.
As if shepherd moons and wavy ringlets weren't strange enough, the rings of Saturn have another, even more baffling feature. In 1980, the Voyager 1 spacecraft sent back images that showed strange, dark, radial features stretching across the vast B ring. They looked like the spokes on a bicycle wheel, sometimes stretching for thousands of kilometers, and they seemed to defy the laws of physics. According to the laws of orbital mechanics, the inner part of the rings orbits faster than the outer part. Any feature that stretched across the rings should be quickly sheared apart, but these spokes seemed to rotate together, as if they were solid features painted onto the rings, keeping their shape for hours at a time before fading away. For decades, they remained a deep mystery. What could possibly be causing them? The Cassini mission finally gave us the answer, and it is stranger than anyone expected. The spokes are not made of different material, and they are not solid. They are, in fact, clouds of tiny, dust-sized ice particles that are being levitated above the main ring plane by electrostatic forces. It is believed that micrometeoroid impacts or electron beams from Saturn's magnetic field can give a patch of the rings an electric charge. This charge causes the smallest dust particles to repel each other and float upwards off the surface of the rings. From our perspective, this cloud of elevated dust looks dark because it scatters sunlight differently than the dense rings below it. They are, in essence, phantoms of static electricity, seasonal dust storms that appear and disappear with the changing influence of the sun on Saturn's magnetic field.
For all their grandeur and seeming permanence, the rings are not a stable, eternal feature. They are, in fact, in a constant state of decay. The rings of Saturn are dying, and they are dying by raining down onto the planet itself. This ring rain is one of the most surprising discoveries from the final days of the Cassini mission. As the spacecraft made its daring dives between the planet and the rings, its instruments detected a constant, heavy shower of particles flowing from the inner edge of the rings directly into Saturn's upper atmosphere. There are two main processes at work. The planet's powerful gravity is constantly tugging on the innermost ring particles, pulling them out of orbit in a slow, steady stream. At the same time, particles throughout the rings are being hit by ultraviolet light from the sun or by tiny micrometeoroid impacts. This can give the ice particles an electrical charge, which allows them to be captured and funneled along the invisible lines of Saturn's magnetic field. These captured particles are then channeled down towards the planet's poles. The amount of material falling into Saturn is immense. Scientists estimate that the rings are losing many thousands of kilograms of mass every single second. At this rate, the entire ring system has a limited lifespan. It is a beautiful but temporary feature. The same forces that sculpt the rings, the planet's gravity and magnetic field, are also actively working to destroy them, pulling them apart piece by piece and consuming them.
This discovery that the rings are actively disappearing leads to the biggest and most profound question of all. Where did they come from in the first place? For most of the 20th century, astronomers assumed the rings were primordial, that they had formed at the same time as Saturn itself, 4.5 billion years ago, from the same great nebula of gas and dust. They were thought to be a permanent and ancient feature. But the evidence now points in a completely different and far more exciting direction. The rings are young, incredibly young in cosmic terms. The fact that they are made of such bright, pure water ice is a major clue. Over billions of years, they should have been darkened and polluted by a constant rain of dusty micrometeoroids. The rate at which the ring rain is draining them also suggests they cannot have been around for billions of years. They would have vanished long ago. The current best estimate is that the rings are only between 10 and 200 million years old. This means they likely formed around the time the dinosaurs still roamed the Earth. So, if they are young, where did they come from? The leading theory is that they are the spectacular, glittering remains of a lost moon. Perhaps a large icy moon, similar to Dione or Tethys, strayed too close to Saturn, passing a critical point known as the Roche limit. Within this limit, the planet's tidal gravitational forces are stronger than the moon's own gravity holding it together. The moon would have been catastrophically ripped apart, its icy body shattering into trillions of pieces that then spread out into the beautiful orbiting debris field we see today. Another possibility is that two of Saturn's icy moons collided, shattering each other in a cosmic cataclysm.
So let us pause here in our journey and consider this remarkable new understanding. The single most iconic and beautiful feature in our entire solar system is not a permanent fixture. It is a temporary spectacle. It is the glittering, beautiful wreckage of a cataclysmic event that happened in our solar system's relatively recent past. The rings are not a serene, peaceful place. They are a crime scene, a debris field, the ghost of a shattered world. This realization imbues the sight of Saturn with a new sense of poignancy and wonder. It means that for the vast majority of our solar system's history, Saturn was just another gas giant, a beautiful but unadorned sphere, much like Jupiter. For billions of years, it had no magnificent rings. And according to the science of the ring rain, in another 100 million years or so, they will be gone, having completely rained down onto the planet. They will have vanished, leaving Saturn once again as a simple, ringless ball. This leads to an incredible conclusion. We are living in the golden age of Saturn. We, as a species, evolved and developed the technology to build telescopes and send spacecraft across the solar system in the exact, brief cosmic window when this magnificent temporary structure exists. If humanity had evolved 100 million years earlier or 100 million years later, our view of the night sky and our understanding of the solar system would be profoundly different. We are uniquely, improbably lucky to be here to witness it.
We pull away from the rings, their vast, icy plain shrinking once again into a perfect, razor-thin line. Our trajectory now carries us towards the immense butter-yellow globe of Saturn itself. The planet fills our entire view, a world with no visible continents, no oceans, no solid ground at all. It is a planet made of atmosphere. As we begin our descent, the first thin, hazy layers of gas begin to whip past us. From here, the rings are no longer a halo around the planet, but a breathtaking silver arch stretching from horizon to horizon across the sky. The sunlight from the distant sun is weak here, casting a pale, golden glow over the cloud tops. We are entering a world of perpetual twilight. The clouds are not the puffy white water ice clouds of Earth. These are clouds of frozen ammonia crystals swirling in vast planet-girdling bands. Below them lie deeper cloud layers of ammonium hydrosulfide, and deeper still, clouds of water ice.
Each layer is colder and denser than the last. We are plunging into a bottomless sky. The journey downward is a journey through ever-increasing pressure and temperature. The winds begin to pick up, at first a strong gale, then a terrifying, unearthly howl. We are entering the domain of one of the most turbulent and energetic atmospheres in the solar system. The serene, placid face that Saturn shows to our telescopes is a lie. Up close, the planet is a barely contained cauldron of storms, winds, and unimaginable energy. Our first destination is its most mysterious and iconic storm, the Great Hexagon at the North Pole.
As we approach Saturn's North Pole, the organized, banded structure of the clouds begins to break down. It gives way to a sight that defies all earthly intuition. Encircling the entire polar region is a colossal, six-sided jet stream. It is a hexagon, a perfect geometric shape, seemingly carved into the atmosphere of a planet. Each of the 6 sides of this hexagon is wider than the entire planet Earth. It is a structure so vast, so strange, and so unnaturally symmetrical that when scientists first saw it in the Voyager images of the 1980s, they were baffled. This is not a solid structure. It is a weather pattern. It is a fast-moving jet stream with winds howling at over 200 miles per hour that has somehow been forced into this stable, 6-sided shape. It rotates with the planet, a permanent, continent-sized hurricane that has been raging for centuries, perhaps millennia. At the very center of the hexagon is the North Pole itself, and there a swirling, organized vortex spins like the eye of a terrestrial hurricane, but one thousands of times more powerful. The sight is mesmerizing. You see the clouds whipping around the sharp corners of the hexagon, maintaining its incredible shape. The structure is a testament to the strange physics that governs rotating fluids on a colossal scale. While storms on Earth are chaotic and unpredictable, the forces on Saturn, the deep, fast rotation, and the lack of a solid surface to disrupt the flow, have allowed this weather pattern to find a strange geometric equilibrium. It is nature creating perfect large-scale geometry, a piece of mathematical art etched into the clouds of a gas giant.
Why a hexagon? Why not a pentagon or an octagon or a simple circle? The question puzzled scientists for decades, but the answer can be found in the fascinating physics of rotating fluids. The hexagon is, in essence, a standing wave, a pattern that has become trapped and stabilized in the polar jet stream. It is a phenomenon that can be recreated in a laboratory right here on Earth. Imagine a bucket of water placed on a spinning turntable. If you spin the bucket at just the right speed, the fluid inside will naturally form rotating polygonal shapes at its center. Depending on the speed and the properties of the fluid, you can create triangles, squares, pentagons, and, yes, hexagons. The fluid, as it tries to find a state of equilibrium between its own internal forces and the rotational energy being applied to it, settles into these remarkably stable geometric patterns. Now, scale that up to the size of a planet.
Saturn's atmosphere is the fluid, and the planet's incredibly fast rotation, a day on Saturn is only about 10.5 hours long, is the turntable. The polar jet stream is a river of wind moving at a different speed than the atmospheric layers around it. This difference in speed creates eddies and waves. On Saturn, the conditions are just right for these waves to lock into a stable six-sided pattern. It is a phenomenon that is natural, if mind-boggling, consequence of physics on a grand scale. The universe, it seems, has a fondness for geometry.
At the very center of this vast hexagonal jet stream lies another, more familiar weather pattern, a colossal polar vortex. Just like the hurricanes on Earth or the Great Red Spot on Jupiter, this is a massive, swirling storm. It is a permanent, low-pressure system locked in place at the planet's north pole. Its eye wall is a towering structure of clouds, and at its center is a calm, clear region, the eye of the storm. But the scale is again difficult to comprehend. The eye of this hurricane alone is 50 times wider than a typical hurricane eye on Earth. It is a storm with enough room to swallow dozens of our own most powerful tempests. The Cassini spacecraft was able to peer deep into this vortex, seeing clouds swirling at terrifying speeds, lit by the pale, distant sunlight. This central vortex seems to be the anchor for the entire hexagonal structure. The jet stream flows around this massive, stable storm, and the interaction between the two is what helps maintain the six-sided shape. It is a storm within a storm, a vortex within a vortex. It is a dynamic, energetic, and incredibly complex system, a weather engine of unimaginable power that has been churning away at the top of the world for longer than human civilization has existed. It is a powerful reminder that even the most orderly and geometric patterns in the cosmos are often born from underlying chaos and violence.
One of the most curious discoveries about the hexagon is that it changes color. When the Voyager probes flew by in the early 1980s during the Northern Hemisphere's winter, the hexagon appeared to be a deep, mesmerizing shade of blue. It was a stark contrast to the pale yellow of the rest of the planet. But when the Cassini spacecraft arrived decades later during the northern summer, the hexagon had changed. It was now a hazy, golden yellow color, much more in line with the rest of the planet. This seasonal color shift is another piece of the atmospheric puzzle. Scientists believe the blue color is the natural color of Saturn's hydrogen-rich atmosphere when it is clear of haze, much like Earth's sky is blue. During the long, 7-year darkness of a polar winter, the lack of direct sunlight causes the aerosols and smog-like particles, the photochemical haze, to dissipate or settle out of the upper atmosphere. This leaves the air clear and allows us to see the deeper, bluer layers. Then, as the seasons change and the pole tilts back towards the sun, the ultraviolet radiation from the sun begins to interact with the gases in the atmosphere once more. This photochemical reaction starts to create new haze particles. Over the course of the long spring and summer, this golden haze builds up, turning the hexagon from blue back to yellow. The hexagon, therefore, is not just a weather pattern. It is a colossal seasonal chemistry experiment,
a visible sign of the planet breathing in and out with the passing of its long, slow years.
While the hexagon is a spectacle of strange geometry, the rest of the planet is dominated by a more straightforward but no less extreme form of weather: wind. Saturn is a world of unimaginable wind. The entire planet is striped with jet streams, rivers of gas flowing eastward at incredible speeds. The fastest of these is the great equatorial jet stream. Here, the winds have been clocked at over 1,800 kilometers, or 1,100 miles per hour. Let us put that into perspective. The most powerful Category 5 hurricanes on Earth have wind speeds of around 160 miles per hour. The winds at Saturn's equator are nearly 7 times faster. They are faster than the speed of sound on Earth. These are not just storms, they are a permanent feature of the planet's atmosphere, a river of wind flowing faster than a fighter jet, endlessly circling the globe. This incredible wind speed is driven by the planet's deep interior heat, a remnant from its formation, and its incredibly fast rotation. Unlike on Earth, where wind is mostly a surface phenomenon, on Saturn, these jet streams are thought to extend deep, deep into the atmosphere, perhaps for thousands of kilometers. They are fundamental to the planet's nature. To be in Saturn's atmosphere would be to be caught in a relentless planet-wide gale that never ever stops. It is a world whose very air is in a constant state of violent, high-speed motion.
Occasionally, the seemingly stable, banded pattern of Saturn's clouds is disrupted by a storm of truly epic proportions. These are known as great white spots. They are not permanent features like Jupiter's great red spot, but are transient, erupting from deep within the planet's atmosphere roughly once every Saturnian year, which is about every 30 Earth years. When one of these storms erupts, it is a spectacular event. They begin as a small, bright white spot, a disturbance in the clouds, but they grow with incredible speed, fueled by the moist, warm gas rising from the planet's interior. Within weeks, the storm can be as large as the Earth. It then begins to stretch and smear out, carried by the planet's powerful jet streams, until it forms a massive, turbulent band of white clouds that can eventually encircle the entire planet. It is as if the planet itself is burping, releasing a huge plume of energy and material from its depths. These great white spots are the most powerful convective storms in the entire solar system. They generate massive lightning discharges and dredge up exotic chemical compounds from the deep atmosphere, giving them their distinctive bright white appearance. Scientists believe these storms are a key part of how Saturn releases its internal heat. For decades, the planet can be calm, building up energy in its interior until it finally erupts in one of these magnificent planet-girdling tempests, a dramatic reminder of the violent engine hiding just beneath the placid cloud tops.
The great white spots are not just visually spectacular, they are also the source of colossal lightning storms. While lightning exists on Earth,
The bolts on Saturn are on another level entirely. They are what are known as megabolts, discharges that can be over 10,000 times more powerful than a typical lightning bolt on Earth. These are not flashes you could see with the naked eye, as they occur deep within the water-ice cloud layer, hundreds of kilometers below the visible ammonia clouds. The Cassini spacecraft could not see these flashes, but it could hear them. Its radio instruments detected the powerful bursts of radio waves produced by the lightning, the characteristic crackle and static of a thunderstorm. By tracking these radio signals, scientists were able to follow the storms as they raged across the planet. During the last Great White Spot, in 2011, Cassini detected hundreds of lightning strokes per second at its peak. Imagine the scene from within those deep, dark water clouds, a sky filled with a constant, silent flickering of unimaginable energy. Flashes of lightning, each one thousands of times brighter and more powerful than anything on Earth, illuminating the turbulent, watery chaos for a fraction of a second before plunging it back into darkness. It is a storm of truly mythological proportions, a thunderstorm of the gods, raging unseen in the depths of the solar system's most beautiful planet.
Our journey now takes us even deeper, leaving the realm of visible clouds and weather behind and entering the truly alien interior of Saturn. As we descend, the pressure and temperature begin to climb at a dizzying rate. The pale yellow ammonia clouds give way to the reddish-brown ammonium hydrosulfide clouds, and then to the familiar white water ice clouds where the lightning rages. But below this, the atmosphere simply continues. There's no surface to land on. The hydrogen gas that makes up most of the atmosphere becomes thicker and thicker, transitioning from a gas into a dense, soupy fluid. The pressure is now millions of times greater than on Earth's surface. The temperature is thousands of degrees. In this extreme environment, the very nature of matter begins to change. We are entering the realm of speculative but scientifically grounded chemistry, and one of the most incredible theories about Saturn's deep interior. The massive lightning storms we detected earlier are not just a spectacle. They are the first step in a chemical process. The powerful electrical discharge zaps the methane gas that is present in Saturn's atmosphere. This blast breaks the methane molecules apart, releasing their carbon atoms. These individual carbon atoms then begin to bond together, forming large clumps of black soot. Imagine a constant, gentle snowfall of fine black carbon powder, beginning its long journey down into the depths of the planet.
This snowfall of carbon soot is where the magic begins. As these fine black particles drift downwards through the thick, soupy hydrogen atmosphere, the pressure around them continues to increase relentlessly. The weight of thousands of kilometers of atmosphere above is pressing down, squeezing them with unimaginable force. At a certain depth, the pressure becomes so great that the loose, amorphous carbon soot is compressed into a new, more stable form, graphite. This is the same soft, gray, crystalline form of carbon that we use to make pencil lead. So now we can picture a rain not of soot, but of solid flakes of graphite, continuing their slow, steady descent into the planet's ever denser interior.
But the journey is far from over. The pressure continues to build, becoming millions of times greater than the pressure at the bottom of Earth's deepest ocean. The temperature is now hotter than the surface of the sun. Under this final, ultimate compression, the graphite itself can no longer hold its form. The carbon atoms are forced into a new, incredibly dense and perfectly stable crystalline structure. The soft gray graphite transforms into the hardest known substance in the universe. It becomes diamond. This is the incredible theory of diamond rain. Deep within the crushing, searing interiors of Saturn and Jupiter, the conditions are right for diamonds to form naturally and rain down through the atmosphere.
Let us follow the journey of one of these incredible raindrops. It starts as a puff of black soot in the upper atmosphere, born from a flash of lightning. It falls for centuries, slowly being compressed into a flake of graphite. Then, deep in the planet's metallic hydrogen interior, it undergoes its final violent transformation. In a flash of pressure, it crystallizes. It is now a diamond. At first, it might be small, a micro-diamond, but as it continues to fall, it may merge with others, growing larger. Scientists speculate that these diamonds could grow to be quite large, perhaps the size of a pebble, a hailstone, or even larger. They are now solid, perfectly formed jewels raining down through a dark, turbulent ocean of liquid metallic hydrogen. It is a scene of unimaginable alien beauty, a treasure trove hidden in the heart of a world where no one will ever see it. What happens to these diamonds? Do they simply fall forever? Eventually, they reach a point deep within the planet where the temperature is so extreme, tens of thousands of degrees, that even the stable structure of a diamond cannot survive. The diamonds themselves would melt, forming a deep global ocean of liquid carbon, a final strange layer in the planet's bizarre interior. The journey that began with a flash of lightning ends with the diamond raindrop dissolving back into a liquid, ready to be cycled back up into the atmosphere by the planet's powerful convection currents, perhaps to one day form again.
After its long journey through the gaseous atmosphere, the liquid metallic hydrogen ocean, and the sea of molten diamond, what lies at the very center of Saturn? What is the final destination? Based on the planet's gravitational measurements, scientists believe that at the very heart of Saturn lies a small, dense core. This is the original seed around which the planet first formed. It is thought to be a mixture of rock, ice, and heavy metals, materials that were common in the early solar system. But it exists under conditions we can barely imagine. The pressure here is tens of millions of times Earth's atmospheric pressure, and the temperature is over 11,000 degrees Celsius, far hotter than the surface of the sun. This core is not solid in the way we think of rock. It is a hot, dense, soupy mixture, a fuzzy core that may be partially dissolved into the liquid metallic hydrogen ocean above it. This intensely hot core is the engine that drives much of Saturn's weather.
It radiates heat outwards, creating the powerful convection currents that churn the atmosphere and eventually lead to the massive great white spots. So, at the end of our journey into the planet, we find not a solid foundation, but a tiny, intensely hot and high-pressure engine room powering the immense and stormy world above it.
We ascend from the crushing pressure and diamond rain of Saturn's interior, back through the layers of clouds, past the shimmering plain of the rings, and into the cold, clear vacuum of space. We have explored the planet and its most famous feature, but the weirdness of this system is far from over. For Saturn is not a solitary object. It is the gravitational anchor of a vast and complex family of more than 140 moons. And if Saturn is the strange and serene patriarch, its children are a carnival of curiosities, a collection of cosmic freaks. This is not like our own solar system's inner sanctum, where the terrestrial planets have only a few relatively simple moons. Saturn's court is a sprawling, diverse, and often baffling collection of worlds. Each one is a unique character, with its own story, its own bizarre geology, and its own set of mysteries. There are giants larger than planets, tiny ice balls erupting with water, two-toned worlds that defy explanation, and moons shaped like household objects. To truly understand why Saturn is weird, we must understand that the planet itself is only the centerpiece. The true weirdness lies in the system as a whole. So let us begin our grand tour of this celestial menagerie. We will hop from moon to moon, exploring the most fascinating members of this family, starting with the largest and, without a doubt, one of the most intriguing worlds in our entire solar system, the Great Moon.
Our first destination is a giant. Titan is the second largest moon in the solar system, larger than the planet Mercury. But as we approach it, we see none of the familiar features of a moon. There are no craters visible, no mountains, no valleys. Instead, all we see is a single, featureless, hazy orange ball. It looks like a small, fuzzy orange star, or perhaps a tiny, perfectly smooth gas planet. The reason for this appearance is Titan's greatest anomaly. It is the only moon in our solar system with a thick, dense atmosphere. And it is not just a thin envelope of gas. Titan's atmosphere is a force to be reckoned with. It is 4 times denser than Earth's own atmosphere. The pressure at its surface is 50% higher than the pressure at sea level on our home planet. If you could stand on Titan, the feeling of the air around you would be more like being at the bottom of a swimming pool than standing in the open. This atmosphere is made almost entirely of nitrogen, just like Earth's, but it is choked with a thick photochemical smog, a haze of complex organic molecules created as sunlight interacts with the methane in Titan's upper atmosphere. This orange smog is what hides the surface from our view. It perpetually shrouds the entire world in a gloomy orange twilight. To understand Titan, we must first pass through this veil, to descend through the orange clouds and see what mysteries lie hidden beneath.
Let us follow the journey of the Huygens probe, which in 2005 made the historic first landing on a world in the outer solar system. As the probe descended through Titan's atmosphere on its parachute, it gave us our first glimpse beneath the orange haze. The view was eerily familiar. The probe's cameras revealed a landscape that looked remarkably like Earth. It saw what appeared to be branching river channels flowing down from highlands and emptying into a vast, dark shoreline. It saw valleys carved by liquid, hills eroded by rainfall, and what looked like sand dunes. It was a landscape that was instantly recognizable, yet utterly alien. Because on Titan, at a temperature of minus 180 degrees Celsius, water is as hard as rock. The rivers are not filled with water, they are filled with liquid methane. The rain that falls from the sky is not water, but liquid methane. The rock that forms the bedrock of the world is not silicate rock, but frozen water ice. Titan has a complete hydrological cycle, just like Earth, with clouds, rain, rivers, lakes, and seas, but it is a cycle of methane, not water. It is a twisted, frozen mirror of our own world. The very substance that we use as a fuel on Earth, natural gas, is the substance that shapes the landscape and fills the oceans of this strange and frigid moon.
After its long descent, the Huygens probe landed with a gentle thud on the surface of Titan. The data it sent back was astonishing. It had not landed on hard bedrock or in a liquid lake. The ground, it seems, was soft, with the consistency of damp sand or crème brûlée. The probe's camera, sitting just inches above the surface, showed a flat alien plain littered with rounded pebbles and stones. But these were not stones made of rock. They were smooth, rounded chunks of water ice, frozen as hard as granite. They had been worn down and tumbled by the flow of liquid methane, just as river rocks on Earth are smoothed by the flow of water. The probe's landing had kicked up a bit of soil, a damp, dark, organic-rich material that contained all the chemical building blocks for life. The landing site was a vast, dry riverbed, evidence of a recent flood of liquid methane. In the distance, the hazy orange sky met the horizon. It was the first and so far only time we have seen the surface of this incredible world up close. It is a landscape of profound alien beauty, a place where the familiar rules of geology and chemistry are turned on their heads, where ice forms the mountains and liquid natural gas carves the canyons.
The methane cycle on Titan is the heart of its weirdness. Just as water on Earth evaporates from the oceans, forms clouds, rains down on the land, flows through rivers, and returns to the sea, methane on Titan does the same. The vast dark seas we see near Titan's poles, like Kraken Mare and Legia Mare, are made of liquid methane and ethane. The warmth of the changing seasons causes this liquid to evaporate, forming thick, fluffy methane clouds in the atmosphere. These clouds then drift across the surface of the moon until they cool and condense, producing torrents
of methane rain. This rain can be a gentle drizzle or a powerful, landscape-altering downpour. The rain carves channels in the water ice bedrock, creating vast, intricate river systems that are visible from orbit. These rivers then flow down into the lakes and seas, completing the cycle. This means that Titan has weather. It has seasons of rain and seasons of drought. It has storms. It has a complex climate system that is hauntingly similar to our own. This discovery was revolutionary. Before we explored Titan, we thought Earth was unique in having a complex weather cycle and liquid on its surface. But Titan showed us that the universe is more creative than that. The same physical processes can occur in vastly different environments with vastly different chemicals. Titan teaches us that the principles of geology and meteorology are universal, even if the ingredients are not.
Beyond its rivers and lakes, the surface of Titan is a landscape of other strange and familiar forms. Vast regions of the moon, particularly around its equator, are covered in enormous fields of dark sand dunes. From orbit, they look just like the great sand seas of the Sahara or Namib deserts on Earth. They are long, linear dunes sculpted by the prevailing winds. But again, the ingredients are alien. The sand on Titan is not made of silicate minerals like quartz. It is made of solid, complex organic molecules, hydrocarbons, that have been created in the upper atmosphere by the breakdown of methane by sunlight. This organic soot slowly rains down, coating the entire moon, and in the dry equatorial regions, it is blown by the wind and gathers into these massive dune fields. Titan may also have a form of volcanism, but not the fiery volcanism of Earth. Here we find cryovolcanoes, or ice volcanoes. Instead of erupting with molten rock, these volcanoes are thought to erupt with a cold, slushy mixture of water, ammonia, and other icy materials from the moon's interior. Features like Doom Mons, a mountain with a deep pit at its summit, are thought to be cryovolcanoes. These eruptions could be a major source of the methane that replenishes the atmosphere, allowing the methane cycle to continue over geological time. A landscape of organic sand and ice volcanoes, it is another layer of beautiful strangeness on this incredible world.
So what does it all mean? Why is Titan so important? This strange, cold world, with its thick nitrogen atmosphere, its organic smog, and its methane cycle, is considered by many scientists to be a chemical laboratory for the origins of life. It is, in essence, a frozen snapshot of what our own planet, Earth, might have been like 4 billion years ago, before life arose and began to fundamentally change our atmosphere. The conditions on early Earth were likely very similar: a thick, nitrogen-rich atmosphere with no oxygen, and a rich soup of organic molecules. The chemistry happening in Titan's atmosphere today, the creation of complex hydrocarbons from simpler molecules like methane, may be the same kind of chemistry that on Earth eventually led to the formation of amino acids, proteins, and life itself. Titan is too cold for life as we know it to exist on its surface, but it is a perfect place to study the chemical pathways that lead to life. It is a preserved, deep-frozen sample of the primordial Earth. By studying Titan, we are in a very real way studying our own origins. It is a priceless window into our own deep past, a way to understand the conditions from which we ourselves emerged. This makes Titan not just a weird moon, but one of the most important and compelling destinations in our quest to understand our place in the universe.
We leave the hazy orange twilight of Titan and journey now to a much smaller, but no less spectacular world. Our next destination is Enceladus. As we approach, it looks like a simple, unassuming snowball in space. It is a small moon, only about 500 kilometers in diameter, and its surface is almost pure white. It is, in fact, the most reflective object in our entire solar system, reflecting almost 100% of the sunlight that strikes it. Its surface is a brilliant, dazzling white, covered in fresh, clean water ice. The surface is also geologically young. While some parts are dotted with craters, vast regions are smooth and almost crater-free, indicating that the surface has been recently repaved or resurfaced. But the most striking features are found at its south pole. Here, the landscape is scarred by a series of long, parallel, bluish cracks in the ice. These are known informally as the tiger stripes. These are not just simple cracks. Thermal imaging from the Cassini spacecraft revealed that the tiger stripes are warm. They are radiating heat from the moon's interior, making them significantly warmer than the surrounding frozen landscape. They are deep fissures in the moon's icy crust, and they are the source of Enceladus's greatest and most spectacular secret. As we watch, we see it. From these blue fissures, a colossal plume of vapor and ice erupts into the blackness of space.
The geysers of Enceladus are one of the most magnificent sights in the solar system. From the tiger stripe fissures at the South Pole, massive plumes of tiny ice crystals, water vapor, and simple organic compounds are blasted hundreds of kilometers out into space. They are, in essence, a series of colossal, continuous cold water volcanoes, erupting not with lava, but with the contents of the moon's interior. The Cassini spacecraft made several daring fly-throughs of these plumes, its instruments sampling their composition directly. What it found was astonishing. The plumes are composed mostly of water vapor, but they also contain simple organic molecules like methane, as well as carbon dioxide, ammonia, and, crucially, salt. The presence of salt indicates that whatever is erupting is coming from a source of liquid salt water. These plumes are the source of Saturn's faint, outermost E ring. The tiny ice crystals ejected from Enceladus go into orbit around Saturn, slowly spreading out to form this diffuse ethereal ring. This tiny moon, hundreds of thousands of kilometers away from the planet, is actively feeding and sustaining one of Saturn's rings with its own internal water. It is a direct, visible link between the geology of a moon and the structure of the ring system, another beautiful example of the interconnectedness of this strange place.
The existence of these salty, organic-rich geysers points to an incredible conclusion, one that has made Enceladus one of the most exciting targets in the search for life. Beneath its shell of solid ice, Enceladus must have a vast, global ocean of liquid salt water. The moon is too small and too far from the sun to be warm enough for liquid water on its own. The heat must be coming from within.
This internal heat is generated by tidal forces. As Enceladus orbits Saturn, the giant planet's immense gravity constantly squeezes and stretches the little moon. This constant flexing and friction generates heat in the moon's rocky core, and that heat is enough to melt the ice from below, creating a warm, liquid ocean trapped between the core and the outer ice shell. The tiger stripes are the weak points in this shell, the cracks through which this pressurized ocean can erupt into space. So we must imagine this world, a bright, placid surface of ice, but beneath it, a dark, globe-spanning ocean of liquid water, perhaps tens of kilometers deep. It is a hidden world, warmed by geothermal energy from the core below. The discovery of this subsurface ocean was a landmark moment, instantly elevating Enceladus from a simple snowball to a world of immense scientific interest. It possesses the single most important ingredient for life as we know it: liquid water.
But Enceladus does not just have water. The Cassini data revealed that it has all three of the essential ingredients for life as we know it. First, as we've seen, there is liquid water in its subsurface ocean. Second, there is a source of energy. The tidal heating that warms the moon's core likely creates hydrothermal vents on the ocean floor, similar to the volcanic vents we find in Earth's deepest oceans. Third, the plumes contain the right chemical building blocks. They are rich in organic molecules, carbon, hydrogen, nitrogen, and oxygen, as well as minerals and salts leached from the rocky core. Water, energy, and organic chemistry. These are the holy trinity for astrobiology. On Earth, the deep-sea hydrothermal vents, which exist in total darkness, are teeming with life. They support entire ecosystems of bacteria, shrimp, and tube worms that thrive on the chemical energy coming from the vents, with no need for sunlight. It is entirely plausible that similar ecosystems could exist at the bottom of Enceladus's dark, warm ocean today. This makes Enceladus arguably the single most promising place in our solar system to search for extraterrestrial life. Not ancient, fossilized life, but living, breathing organisms. While it would be a huge technological challenge, a future mission could be designed to land on Enceladus, drill through the ice shell, and send a submersible down into that hidden ocean. What it might find there is anyone's guess, but the possibility is tantalizing.
Our journey now takes us further out, to one of Saturn's more distant and more peculiar moons, Iapetus. From the moment it was discovered in the 17th century, Iapetus has been a puzzle. The astronomer Giovanni Cassini noticed something very strange. He could only see the moon when it was on one side of Saturn in its orbit. When it moved to the other side, it completely vanished. He correctly deduced that the moon must be two-toned, with one side being bright and reflective, and the other side being incredibly dark, making it invisible against the blackness of space. He was right. As our imaginary spacecraft approaches Iapetus, we see this incredible dichotomy firsthand. It is a world split perfectly into two distinct hemispheres. The leading hemisphere, the one that faces forward in its orbit, is as dark as fresh asphalt, reflecting almost no light. The trailing hemisphere and the poles are as bright as fresh snow. The dividing line between the two is sharp and distinct. It is often called the yin-yang moon, a perfect sphere of black and white.
The prevailing theory for Iapetus's strange coloration involves another of Saturn's moons, the distant, dark, and unruly Phoebe. Phoebe is an outsider. It is a captured object from the Kuiper belt that orbits Saturn backwards or in a retrograde direction. It is also very dark and dusty. As tiny micrometeoroids impact Phoebe, they kick up a faint, dark, reddish dust. This dust then spirals inward towards Saturn, forming a massive, incredibly faint, and diffuse ring of its own, the largest but most invisible of all of Saturn's rings. Iapetus, in its own orbit, plows directly through this faint cloud of dark dust. Because Phoebe orbits backwards, Iapetus collides with this dust head-on. This means that its leading hemisphere is constantly being coated with a thin layer of this dark reddish material from Phoebe. It is like driving through a swarm of insects. Only your front windshield gets dirty. This explains why one side is dark. But why is the other side so bright? The dark material absorbs a little more sunlight than the bright ice, causing it to warm up slightly. In the cold vacuum of space, this tiny amount of extra heat is enough to cause the bright water ice on the dark hemisphere to sublimate, to turn directly from a solid into a gas. This water vapor then drifts around the moon and recondenses as frost on the coldest parts of the surface, which are the trailing hemisphere and the poles. So the dark side gets progressively darker as it collects dust, and the bright side gets progressively brighter as it collects frost. It is a runaway thermal effect, a beautiful, self-reinforcing process that has, over millions of years, created this stunning, two-faced world.
As if its bizarre coloration weren't enough, Iapetus has another, equally baffling mystery. Running almost perfectly along its equator is a colossal mountain range. This is not just a collection of peaks. It is a sharp, well-defined ridge that is over 1,300 kilometers long and, in places, over 10 kilometers high, twice the height of Mount Everest. It gives the moon the distinct appearance of a walnut, or two halves of a sphere that have been crudely welded together. The origin of this equatorial ridge is one of the greatest unsolved mysteries of the Saturnian system. There are several competing theories, but none of them are entirely satisfying. One idea is that Iapetus once had a ring of its own, perhaps formed from a smaller submoon that was destroyed. This ring material could have then slowly rained down onto the moon's equator, building up this massive ridge over millions of years. Another, more exotic theory is that Iapetus used to rotate much faster when it was young and still forming. This fast rotation could have caused its crust to bulge out at the equator, forming the ridge. As the moon cooled and its rotation slowed down due to tidal forces from Saturn, this equatorial bulge froze in place, becoming the permanent feature we see today. Whatever its origin, the ridge adds another layer of deep strangeness to this already peculiar world, a geological puzzle waiting to be solved.
We now leave the larger moons behind and begin a final, rapid tour of some of the smaller, but no less weird, members of Saturn's family. Our first stop is Mimas. As we approach, its defining feature becomes immediately and comically apparent.
One entire side of the Moon is dominated by a single colossal impact crater. This is the Herschel crater, named after the Moon's discoverer. It is 130 kilometers wide, almost a third of the Moon's entire diameter. At the center of the crater is a massive central peak, itself as tall as Mount Everest. The sheer scale of the crater in relation to the Moon gives Mimas the unmistakable appearance of the Death Star from the Star Wars films. The impact that created this crater must have been absolutely immense, an event that came terrifyingly close to shattering the little Moon completely. Mimas is, in essence, a celestial survivor, a world defined and forever scarred by a single cataclysmic event from its past. Its weirdness lies in its own improbable existence. It also presents a puzzle. Mimas is a simple ball of ice, closer to Saturn than Enceladus, and subject to similar tidal forces. Yet it is a geologically dead world, while Enceladus is bursting with life-giving energy. Why one ice moon is active and the other is dead is another one of the many mysteries that the Saturn system holds.
Next, we dive back into the rings to visit two of the strangest shaped objects in the solar system, Pan and Atlas. These are two of the tiny shepherd moons we spoke of earlier, and their proximity to the rings has sculpted them into something truly bizarre. They are not spheres. They are not even potato-shaped. They look like celestial ravioli, or perhaps classic science fiction flying saucers. Both Pan and Atlas orbit within gaps in the A-ring. Over millions of years, they have been sweeping up the fine, dusty ice particles from the rings. But this material hasn't just coated them. Because of their fast rotation, the loose material has been flung outwards by centrifugal force and has accumulated around their equators. This has built up a prominent, thin, flying saucer-like ridge of loose, fluffy material around the equator of each moon. The result is a small, solid core with a wide, flattened equatorial skirt of ring material. They are moons that are actively wearing a piece of the rings. Their strange shape is a direct, visible consequence of their environment. They are a perfect, beautiful example of the constant, intimate interaction between the rings and the moons, a physical record of their long history as cosmic shepherds and street sweepers.
Our tour of the weird little ones continues with a visit to Hyperion. If Pan and Atlas are strangely ordered, Hyperion is the embodiment of chaos. As we approach, we see that it is not spherical at all. It is a lumpy, oblong, potato-shaped object. Its surface is even stranger. It is covered in deep, sharp-edged, cup-like craters, making it look less like a moon and more like a giant porous sea sponge or a piece of cosmic coral. The bottom of these craters is covered in a dark, reddish material while the rims are bright and icy. But Hyperion's strangest feature is its orbit. It does not spin in a regular, predictable way. It is in a state of chaotic rotation. This means that its axis of rotation tumbles unpredictably over time. You can never predict which part of Hyperion will be pointed towards Saturn at any given moment. Its day has no consistent length. Its poles wander all over its surface. This is because it is locked in a gravitational resonance with the giant moon Titan, which orbits nearby. Titan's powerful, regular gravitational tugs prevent Hyperion from ever settling into a stable spin. Hyperion is a world that has been beaten up and bullied by its larger neighbor. It is a tumbling, chaotic, sponge-like remnant, a testament to the powerful gravitational forces that govern this complex system. It is weird not because of some strange internal process, but because of the violent and unpredictable neighborhood in which it lives.
We conclude our tour by visiting the bookends of the Saturnian system, the innermost shepherds and a great distant outsider. We revisit Prometheus and Pandora, the two small moons that shepherd the F-ring. Up close, we can see that they are not smooth, but are elongated, potato-shaped worlds pockmarked with craters. They move in a complex, chaotic dance around the F-ring, occasionally swapping orbits and dipping into the ring itself. When Prometheus gets close, its gravity pulls long, streamer-like channels and knots out of the faint ring material, temporarily disrupting the very structure it helps to maintain. They are messy, imperfect shepherds. Then we travel far, far out to the distant edges of the system to meet the final member of our carnival, Phoebe. Phoebe is nothing like the other moons we have visited. It is dark, almost black. It is irregular and heavily cratered, and most importantly, it orbits Saturn backwards. While all the other major moons orbit in the same direction as Saturn's rotation, in a neat, flat plane, Phoebe goes the wrong way in a tilted, eccentric orbit. This tells us that Phoebe is not a native of the system. It was not born here. It is a foreigner, a captured object. It is most likely a centaur, a body from the Kuiper belt beyond Neptune that was captured by Saturn's immense gravity long ago. It is a dark, primitive relic from the outer solar system, a visitor that never left. And as we discovered with Iapetus, this dark, dusty outsider is responsible for staining its fellow moons, proving that even the most distant members of this family have a profound effect on the others. Our journey is now complete. We have seen the impossible planet that would float in water. We have soared through the glittering, temporary ruins of a shattered moon that form its rings. We have plunged into an atmosphere where storms are the size of planets and it rains diamonds. And we have toured a bizarre family of moons, from the primordial world of Titan to the life-giving ocean of Enceladus, from the two-faced Iapetus to the Death Star Mimas and the sponge-like Hyperion. So now we can finally return to our original question: why is Saturn weird? The answer we can now see is that Saturn is not a single weird object. It is a weird system. It is a place where everything is deeply and complexly interconnected. You cannot understand the planet without understanding its moons. The tilt of the great planet itself is dictated by the slow, outward dance of its largest moon, Titan. You cannot understand the rings without understanding the moons. They are likely the shattered remains of a lost moon. Their intricate structure is constantly being sculpted and maintained by the tiny shepherd moons that act as their guardians. And the rings themselves are fed by the icy plumes of the erupting moon Enceladus. The moons, in turn, are defined by their relationship with each other and the planet. Enceladus is kept warm by the gravitational squeezing of Saturn.
Iapetus is painted black by the dust of the captured moon Phoebe. Hyperion tumbles chaotically because of the influence of Titan. Nothing here exists in isolation. It is a vast, intricate, and deeply weird gravitational machine. The story of Saturn is, in many ways, the story of modern planetary science. For centuries, it was just a beautiful, mysterious point of light in our sky. But with the arrival of our robotic emissaries, Pioneer, Voyager, and especially the great Cassini mission, which orbited the planet for 13 years, we have peeled back the layers of this system and revealed a place more complex and wonderful than we ever could have imagined. And the most beautiful part of this story is that for every question we have answered, a dozen new, even more profound mysteries have appeared. We now believe the rings are young, but we don't know for sure what destroyed the moon that formed them. We have found a vast, warm, salty ocean on Enceladus that contains all the ingredients for life, but we do not know if anything actually lives there. We see a landscape of rivers and lakes on Titan, but we do not know what strange, cold, prebiotic chemistry is taking place in them. We see a colossal mountain range girdling Iapetus, but we have no certain explanation for how it got there. Saturn is not a puzzle that has been solved. It is a treasure chest that has just been opened. It is a reminder that our solar system is not a static clockwork mechanism of simple, predictable spheres. It is a dynamic, evolving, and often chaotic place, filled with wonders that challenge our imagination. The weirdness of Saturn is a gift. It is a cosmic invitation to keep exploring, to keep asking questions, and to stand in perpetual awe of the beauty and complexity of the universe.
So, as we take our final, lingering look at this magnificent system, the great golden planet, the shimmering icy rings, and the dozens of tiny points of light that are its strange and varied moons, we are left with a sense of profound wonder. We have journeyed from the impossible vision in a telescope to the intricate dance of shepherd moons, from the bizarre geometry of a polar storm to the tantalizing promise of a life-bearing ocean. We have learned that this serene, peaceful-looking jewel is in fact the site of unimaginable violence and energy. It is a place of storms more powerful than any on Earth, of cataclysmic collisions that shattered worlds, and of constant, graceful destruction as the rings rain down onto the planet that created them. It is a world of breathtaking contradictions. The story of Saturn teaches us that the universe is not obligated to make sense to our earthbound intuition. It can be more creative, more bizarre, and more beautiful than our imaginations can often conjure. It is a lesson in humility and in awe. It reminds us that there are still great mysteries left to solve, great journeys to be undertaken, and great wonders waiting to be discovered, right here in our own solar system.
And so, our long journey through the Saturnian system comes to a peaceful end. We leave behind the diamond rain, the methane lakes, and the icy geysers, and return to the quiet darkness of our own small corner of the cosmos. Thank you for joining me on this exploration of the solar system's strangest and most beautiful world. May the cosmic wonder of Saturn inspire your dreams, and may the rest of your night be filled with deep and peaceful rest.